Good evening, Dr. Jones and fellow peers. My name is Onaysha Lambert. Bacteria, both harmful and harmless, surround everything we eat, drink, breathe, and touch. So what if I told you there was a bacteria that can wipe out the industries of agriculture and aquaculture in poor countries where these industries are heavily dependent on? Today I will be informing you on whole genome sequencing of Streptococcus parvovirus and discussing its impact on these two industries. I chose to inform you about this bacterium because it's important to be aware of the many bacteria that surround us. Also, as a biologist, studying the genes that enable these bacteria to be harmful can lead to vaccines, medicine, and other preventatives. I will be introducing Streptococcus parvovirus to you and describing what it is, reviewing materials and methods used to do whole genome sequencing, and discussing real-life application of the study. My references include molecular taxonomic studies on Streptococcus parvovirus types 1 and 2 by Annette Williams and M.D. Collins, published on March 11, 2008 by the Journal of Applied Bacteriology. PROCA, Rapid Prokaryotic Genome Annotation by Seaman T., published on July 15, 2014. Streptococcus in Cultured Turbot by L. Dominguez, published in 1996 from the Journal of Fish Diseases. First report of Streptococcus parvovirus in wild fish from North America by A. Haynes and David Gaudier, published on May 20, 2013 from the Veterinary Microbiology. And last but not least, isolation and identification of hyperammonia producing bacteria from swine manure storage pits by T.R. Whitehead and M.A. Cotta, published in 2004 from Current Microbiology. In order to understand the importance of this study, I will first explain to you what Streptococcus parvovirus is. Streptococcus parvovirus is a gram-positive coccus-shaped bacteria that infects fish and causes mastitis in cows. In fish, it is known to cause skin lesions, necrosis, and meningitis, as stated by my references, Williams and Collins. It was first reported to infect the kidneys, spleen, and liver in cultured turbot in 1993, but since then it has infected fish such as the wild striped bass in the United States and olive flounder in Korea and Japan. Streptococcus is important as a pathogen because it serves as what we call environmental generalists. Environmental generalists have genomes that allow them to adapt to different niches and become patches of new hosts. Streptococcus parvovirus can flourish in many different environments, including the cow udder, soil, sediment underwater, fish, and also salt water. According to my resources, this bacterium is able to adapt to such a wide range of different niches through the addition and deletion of many genes. Use this bacterium as a model for environmental generalists can enable us to determine which genes are vital and important for them to adapt to different environments and become patches of new hosts. So if you look over here, we have a variety of different niches, and you have the cow udder, where you can find the bacteria, cow manure, soil, salt water, fish, and sediment underwater. In order to determine the genes that are needed to make this bacterium so adaptable, there has to be many materials and methods done to do so. The first method is what we call sequencing. Sequencing basically means determining the order of A's, T's, C's, and G's in a given nucleotide fragment. This is done with a piece of equipment called the Illumina high-seq sequencer, which accomplishes this by using 2 by 125 base pair paired-end sequencing. And what this means is 2 identical copies of DNA are both sequenced at the same time to ensure precise and more accurate sequencing. Next, the second step is what we call assembly. Assembly is basically putting the sequence fragments together into what we call contigs. My sources indicate that contigs are basically big jumble or chunks of pieces of DNA. The program we use to do assembly is called Celery. Celery uses de novo assembly and not reference assembly, in which it does not use a reference genome to put the genome together or to assemble it. It is said that de novo assembly gets better because if the reference did not match to the reference genome, if the assembly did not match the reference genome, it would not throw away or chunk out any important piece of DNA that we may need. Lastly, after assembly, they annotated the genome with a program called PROCA. PROCA is a software that uses Unix-based command lines in order to fully annotate bacterial genomes. And it does this by identifying stop and start codons and predicting the proteins for the genes. So if you look over here, you have a whole genome, and it's broken down into fragments to be sequenced in the sequencing step. Then it's put together again or assembled in the assembly step into these things called contigs. After annotation of the S. paribus genome, real-life application of the study can be done in order to prevent loss in the agriculture and aquaculture industries. The study can help to look into single nucleotide polymorphisms and create phylogenetic trees. This basically is how the change of one nucleotide in the fragment can create a whole new bacterial species or make a whole new gene. This will also help us to possibly make an attenuated vaccines for fish in aquaculture and animals in agriculture. So the fish will get vaccinated and also the cows. Lastly, we can compare genomes to prove that single nucleotide polymorphisms can actually contribute to why S. paribus can adapt to many niches in different hosts. So if you look at this picture over here, you have a phylogenetic tree. It's also called an evolutionary tree. So you would see that as Streptococcus itself started as one genome, but then over time it eventually evolved into different types of bacteria. So are there any questions? Yes, T.
Is this bacteria harmful to humans?
This bacteria is not harmful to humans. It is not a human pathogen. A bacteria that you may be familiar with is Streptococcus pyogenes, and that's actually the bacteria that causes strep throat in humans. However, it is not Streptococcus paribus. They're related, but Streptococcus does not affect humans, but pyogenes. Streptococcus paribus does not affect humans, but Streptococcus pyogenes does. If that answers your question. Next. Yes, Leah.
Okay, you said that the bacteria is gram-positive. What does that mean?
Gram-positive basically means that the bacterial cell wall is covered by a peptidoglycan cover. So what that means is when you stain bacteria to view under a microscope, it actually stains purple. If it were gram-negative, it would stain pink. So if that answers your question, that's what that means. Yes, Lyric.
You said that the bacteria was first identified in fish, but is there any theory of how it began to infect cattle?
A theory that researchers have is that the cattle actually drank the water that the fish was in. So you can see how that kind of would infect them too, because the fish are in the water. But as far as a true theory or a reason why, I'll have to get back to you on that. Yes.
Can you describe again why de novo assembly is better than reference assembly?
That's a good question. De novo assembly is better because, say you were to have a reference genome that you were trying to assemble your genome to. Well, if you had a reference genome, the computer would go, okay, well, this matches, that matches, this matches. But if you had a chunk of DNA that didn't match, the computer would go, well, I don't know what to do with it. And it'll just chuck it out and throw it away. So you don't want that to happen because those differences you kind of want to account for because you want to see, okay, what does this fish have and what does this cow have in order for the bacteria to live in it and live in this and, still be the same bacteria. So you kind of want those different pieces of DNA. You don't want the computer to throw it out or mark it as, unusable or, stuff like that. Is that all questions? So in conclusion, Streptococcus paribus is a bacterium that heavily infects fish and aquaculture and cattle and agriculture. Through sequencing, assembling, and annotating, Streptococcus paribus, it is possible to develop ways to prevent the spread of bacterium and lessen its harmful effects. Thank you all, for the questions. I really appreciate it, and thank you.